Artificial intelligence is the theory and development of computer systems able to perform tasks that normally require human intelligence, such as visual perception, speech recognition, decision-making, and translation between languages. Artificial intelligence is a computer system running a simulation of human intelligence. It's mostly known as AI and is not the same as machine learning, where the machine picks up or learns skills. AI is capable of making their own decisions based on commands or just randomly. Artificial intelligence has a huge impact on society today as a whole. It affects many aspects in life, from jobs to common world and political problems. In the near term, the goal of keeping AI's impact on society beneficial motivates research in many areas, from economics and law to technical topics such as verification, validity, security and control. There are many ways that AI can replace human thinking, like stock exchanges. For instance, high-frequency trading by machines has replaced much of human decision-making. AI can be used to solve an array of environmental problems, such as climate change and natural calamities prediction. Studies estimate that artificial intelligence technologies could increase global GDP by $15.7 trillion, a full 14%, by 2030. As you can see, AI is used all around us, but today we are gonna be focusing AI in the workplace. AI in the workplace can be very beneficial to a company due to its efficiency, and it can do what a human does, faster and better. It's also cost-effective. But before we get into AI in the workplace, let's get into the benefits and risks of AI. Benefits of AI are how it enhances efficiency. AI today is a huge benefit to society because it enhances our efficiency and throughput, while creating new opportunities for revenue generation, cost savings. The rise of AI in our society will enhance our lifestyle and create more efficient businesses. Some of the mundane tasks like answering emails and data entry will be done by intelligent assistants. Smart homes will also reduce energy usage and provide better security. Marketing will be more targeted, and we will get better healthcare thanks to better diagnoses. There will be economic consequences to the widespread adoption of machine learning and other AI technologies. AI is capable of performing tasks that would once have required intensive human labor or not have been possible at all. The major benefit for business will be a reduction in operational costs brought about by AI automation. Much of the fear with AI is due to the misunderstanding of what it is and how it should be applied. Although AI has promise for solving complex social problems, there are ethical issues and biases we must still explore. We are just beginning to understand how AI can be applied to meaningful problems. As our use of AI matures, we will find it to be a clear benefit in our lives. Artificial intelligence can range from the virtual assistant in your iPhone, Siri, to robots that can do the same exact things as humans do, without any interaction from a human. Better yet, they can do everything a human can do but better. There are 4 stages in artificial intelligence: reactive machines, limited memory, theory of mind, and self-awareness. The most basic types of AI systems are purely reactive, and have the ability to neither form memories nor to use past experiences to inform current decisions. Deep Blue, IBM's chess-playing supercomputer, which beat international master of chess, Garry Kasparov, in the late 1990s, is the perfect example of this type of machine. Deep Blue can identify the pieces on a chessboard and know how each moves. It can make predictions about what moves might be next for it and its opponent. And it can choose the most optimal moves from among the possibilities. But it doesn't have any concept of the past, nor any memory of what has happened before. Apart from a rarely used chess-specific rule against repeating the same move 3 times, Deep Blue ignores everything before the present moment. All it does is look at the pieces on the chessboard as it stands at the moment, and chooses from possible next moves. This type of intelligence involves the computer perceiving the world directly and acting on what it sees. It doesn't rely on an internal concept of the world. The current intelligent machines we marvel at either have no such concept of the world, or have a very limited and specialized one for its particular duties. The innovation in Deep Blue's design was not to broaden the range of possible movies the computer considered. Rather, the developers found a way to narrow its view, to stop pursuing some potential future moves, based on how it rated their outcome. Without this ability, the Deep Blue would have needed to be an even more powerful computer to actually beat Kasparov. This Stage 2 class contains machines that can look into the past. Self-driving cars do some of this already. For example, they observe other cars' speed and direction. That can't be done in just one moment, but rather requires identifying specific objects and monitoring them over time. These observations are added to the self-driving car's pre-programmed representations of the world, which also include lane markings, traffic lights and other important elements, like curves in the road. They're included when the car decides when to change lanes, to avoid cutting off another driver or being hit by a nearby car. But these simple pieces of information about the past are only transient. They aren't saved as part of the car's library of experience it can learn from, the way human drivers compile experience over years behind the wheel. We might stop here, and call this point the important divide between the machines we have and the machines we will build in the future. However, it is better to be more specific to discuss the types of representations machines need to form, and what they need to be about. Machines in the next, more advanced, class not only form representations about the world, but also about other agents or entities in the world. In psychology, this is called theory of mind, the understanding that people, creatures and objects in the world can have thoughts and emotions that affect their own behavior. This is crucial to how we humans formed societies, because they allowed us to have social interactions. Without understanding each other's motives and intentions, and without taking into account what somebody else knows either about me or the environment, working together is at best difficult, at worst impossible. If AI systems are indeed ever to walk among us, they'll have to be able to understand that each of us has thoughts and feelings and expectations for how we'll be treated. And they'll have to adjust their behavior accordingly. Lastly, the final step of AI development is to build systems that can form representations about themselves. Ultimately, AI researchers will have to not only understand consciousness, but build machines that have it. This is, in a sense, an extension of the theory of mind possessed by Stage 3 artificial intelligences. Consciousness is also called self-awareness for a reason. Conscious beings are aware of themselves, know about their internal states, and are able to predict feelings of others. We assume someone honking behind us in traffic is angry or impatient, because that's how we feel when we honk at others. Without a theory of mind, we could not make those sorts of inferences. While we are probably far from creating machines that are self-aware, we should focus our efforts toward understanding memory, learning and the ability to base decisions on past experiences. This is an important step to understanding human intelligence on its own. And it is crucial if we want to design or evolve machines that are more than exceptional at classifying what they see in front of them.